Hello guys, welcome once more to class online. My name is Tutor Dami, and in this video we shall be looking at Waec Physics 2016 question number 21 to number 25, and we shall be dealing with Waec. Now don't forget that if you really learn something from this video, to click on the like button. We have much content to share with you that will help you better understand physics. Now let's get down to question number 21. The continuous stirring in the method of mixture to determine the specific thermal capacity of a substance ensures what? Now, is it A, continuous dissipation of heat to the room, B, uniform distribution of thermal energy to all the parts of the mixture, C, that thermal energy is confined to the mixture, and D, that there is rapid heat exchange. Now, this question is asking you about when you are performing the experiment of specific heat capacity in your laboratory. Why do you stir? As in, there is stirrer in the calorimeter. Now, why is the stirrer there? And what's the function of the stirrer? Do you have any idea which option might be right? Now, actually, I went on to explain how the experiment is performed. First, the calorimeter and the stirrer is weighed. You can see the picture here. I drew the calorimeter and I drew the stirrer. Next, the water is added to the calorimeter and the stirrer, and it is weighed also. That's weight 2. Then the solid is weighed. Then the temperature of the ordinary water is taken. Then the temperature of the metal inside the water is taken after the metal has been heated. So the temperature is taken, and finally you see the stirrer. You put in this one is the metal is being heated and prepared to be put inside the calorimeter. And here, the metal is placed in the calorimeter and the temperature is taken, and there is a stirrer. Now, the function of the stirrer is this. We stir until the temperature is evenly distributed, and that is the simple reason why we stir. Now, if we don't stir, the heat in the solid, here we heated the metal. We heat the metal was heated. Now, it was transferred quickly into the calorimeter to transfer heat to the water, that's to the liquid in the calorimeter. Now, but the stirrer is there to make the heat transfer of the solid to the calorimeter to be effective. So now the stirrer is to stir it so that the heat of the from the metal will be distributed around the water evenly. So the function of the metal of the stirrer is simply to distribute the heat within the liquid easily. That's to make the heat to circulate the liquid, and that's the purpose of the stirrer. So that brings us to the answer B, uniform distribution of thermal energy to all parts of the mixture. That is why we have that stirrer. That spoon is there to stir and to uniformly distribute the heat, and that is the simple answer to the simple question. Let's check out number 22. It says, which of the following statement is correct about the effect of dissolved salt on the freezing point of water? Now, that dissolved salt, when you put salt in water, that is an impurity, right? Now, this question is indirectly saying, what is the effect of impurity on freezing point? Now, freezing point is the inverse of melting point. They are almost the same thing. They both happen at 0 degrees Celsius, but they happen in opposite direction. Now, melting comes to bring solid to liquid, while freezing brings liquid to solid. Now, but what is the effect of salt, which is an impurity in water? Now, because the reason why it is impurity is because salt and water are not the same. So if you put what is not the same in something, then that thing has become contaminated in science. So it's not that it is dirty. No, it is just that it is not the same material. So that's impurity in water. So what's the implication of impurity in on the freezing point? Does the freezing point lower, or does it increase the freezing point, or there is no exchange in the freezing point? There is no change in the freezing point, or the change in the freezing point depends on the temperature of the surrounding. Which of them do you think might be correct? Now, this is it. I just simplify it here. Impurity on boiling point, it increases. Impurity on melting and freezing point, it decreases. So impurity, which is salt, decreases the freezing point. This topic is a very important topic towards that you will learn towards the second term in SS2 when you are learning physics. You'll be learning this topic with something like a regeneration experiment. And this is where we learn about boiling point and evaporation, and we learn that evaporation causes cooling. So now, but the implication of impurity on melting point is that it makes the melting point to decrease. So impurity decrease the melting point as it makes the boiling point to increase. That if the water is not pure, if you put salt in water, the water will not boil at 100 degrees Celsius. The boiling point of the water will increase because impurity makes it difficult for water to boil. But if you put impurity in salt, in water, that's impurity like salt in water, it will lower the melting point. That means the water, the melting point of the water will go down. That means it will take time for the water to melt. Like if you have ice now for the ice that has salt to dissolve, it will take longer time. It will lower the melting point beyond normal. So the implication of impurity is that it lowers melting point, and that is the answer. The freezing point or the melting point will be lower. It lowers the freezing point, and that is the answer to the question. It lowers the freezing point. That means it makes it difficult to freeze, and that is the answer to that question. Now let's get down to number 23. A pressurized perfume bottle is left on fire window plane for a room. What happened to the gas molecule of the perfume on a sunny day? Now, if you leave your perfume at the window and you go to work, like let's say that you have to go to work and you forgot your perfume by the window, and the ray of the sun is shining on the perfume, what will happen to the perfume? Now, will it expand? Will it collide less often? Will it move more quickly? That should be quickly. And will it contract? Contract means it will shrink or become smaller. Expand means it will become larger. Now, what do you think might be correct? Now, is it expansion A, B, C, D? Now, actually, let's take a look at that. Now, what will happen to that question? To that perfume is simply that it will expand. And the reason is this: whenever any material is heated, in science we've learned that whenever anything is heated, whether liquid or solid or gas, if it is heated, it naturally expands. And that's the simple phenomenon. As in, this is direct, it's a direct question. Whenever something is heated, now the ray of the sun is going to heat the perfume, and it will cause expansion. And if it is a tough glass, the glass might crack, because expansion makes glasses to crack, and it can shatter if it becomes too much. So that, but what will happen to the perfume is that it will begin to expand, and that is the answer because of heat of the sun. The sun ray will cause the perfume to expand, and that's the answer for number 24, A, expansion. Number 24 now, given that V, F, and lambda are the velocity, frequency, and wavelength of a wave respectively, which of the following equation is correct? Now, do you have any idea which one is correct? Now, this formula that combines velocity, frequency, and lambda, that's wavelength, is very popular in science. Now, what I'm saying is that it is popular because it cuts across many areas in physics. Now, this formula can be used for many applications, and this formula is simply the formula that you get when you are talking about motion for the first time. From the introduction to motion, you will get to know, you will be introduced to this formula under the velocity of, not motion. From the introduction to wave, you will be introduced to this formula under the speed of wave. Now, the formula is simply this: V equals F lambda, and that is the formula. But it was not written in this form among the options. The only form where it is written among the options is the option that have frequency as the sort of formula. And that's what I'm saying is V equals F lambda, right? Now, the frequency is therefore, in the second case, if you make frequency the subject, that means lambda will leave frequency. If you go under the V, frequency will then be V over lambda. And that is the only form we have in the option, and that is option B. That's the only form we have in the option, and that's option B. Frequency is V over lambda, and that is correct. So that's the answer to the question. Don't forget, this formula is very important. This formula is one of the strongest formula I personally have seen in physics, and the reason is because it can solve questions on sound wave. It can solve questions on ordinary wave. It can solve questions on photoelectric effects. So this formula is very, very important, and I want to say this: you should not forget this formula. It's very, very important, and it will help you answer many questions in wave. So the natural form of the question of the formula, the best form among the options that reflect the formula, is F equals V over lambda, and that is the answer to the question. F equals V over lambda, and that is number 24. Now let's check out number 25, which is the last one for this video. Three daughters are placed in front of a plane mirror as illustrated in the diagram below. The image form is illustrated by what? Is it you can see that is gel. Now you are to mirror that gel. What do you think might be correct? Which one do you think might be correct? That's right. Now let's see. This is it. Gel, when mirrored, the beginning from the L is the closest to the mirror. It will turn backward this way, facing the mirror, and the E is the next closest. It will turn this way, facing the mirror, because the E here was facing the mirror. Here also it will face the mirror. The L here was facing the mirror. Here it will face the mirror plane, and then the J was facing the mirror. Here it will also face the mirror. So it will begin from the closest to the mirror, L facing the mirror, E facing the mirror, and J facing the mirror. And this is called lateral inversion. This is the mirror effect, and this is the answer to the question. So it will become this form. And let's see which option reflects that. It is just this. Actually, this is not even reflecting it well. The E is supposed to be turned backward, and that is the form. So this is supposed to be the answer if the E is turned backward. So this was not well done. So the answer is naturally, take note, the answer is this format, and that is the answer for the lateral inversion of mirror. I hope this is clear. Now this video to the end of this video. Don't forget that if you learn anything from this video, to click on like button. We have more content to show you that will better help you understand physics. Until we see next time, guys, take care of yourself and bye for now.